June 1942, a farmhouse in occupied France. German soldiers tear through hay bales searching for contraband. They find a single brass cartridge, 9mm, stamped with British markings. Under German occupation law, illegal possession of firearms meant death. Within hours, the family faces the consequences. All because of one bullet for a gun that cost less than a restaurant meal to manufacture. The Sten submachine gun terrified Nazi occupation forces more than any tank, any bomber, any battleship in the Allied arsenal. Not because of what it could do to a single German soldier, but because of what it represented. Organized British resistance, weapons falling from the sky, the certainty that any civilian anywhere in occupied Europe might be armed and waiting. The weapon transformed the relationship between occupier and occupied. German occupation authorities across Europe issued brutal decrees against weapons possession in Norway, France, Poland, and the Netherlands. Discovery of British-supplied arms triggered immediate reprisals. Families executed, farms burned, villages destroyed as collective punishment. The Germans understood something that military historians would later confirm. This crude, cheap, desperately ugly weapon changed the mathematics of occupation forever. Consider the numbers. A Panzer IV tank cost approximately 115,000 Reichsmarks to manufacture. A single Tiger I consumed enough steel, labor, and precision engineering to build 40 Sten guns. Yet in the narrow streets of occupied Paris, in the forests of Norway, in the rubble of Warsaw, tanks meant nothing. What mattered was the weapon hidden beneath the floorboards, waiting for the right moment, the vulnerable target, the chance to strike and vanish. The Sten emerged from catastrophe between May 26 and June 4, 1940. The British Expeditionary Force evacuated from Dunkirk. They saved 338,000 men. They abandoned everything else. Over 11,000 machine guns lay rusting on French beaches. 2,500 artillery pieces, 65,000 vehicles. Britain faced potential German invasion with a military stripped of automatic weapons. The crisis extended beyond equipment losses. British factories were already operating at maximum capacity, producing rifles, artillery, and aircraft. Retooling for submachine gun production would take months the nation did not have. German invasion barges were being assembled across the channel. Intelligence suggested Operation Sea Lion could launch within weeks. The American Thompson submachine gun offered one solution. It was beautifully engineered, devastatingly reliable, and completely unaffordable. Each Thompson cost $200 in gold currency, and American factories were consumed by their own rearmament. Britain needed millions of submachine guns. At Thompson prices, they could afford thousands. Even the reduced wartime Thompson MA1 cost $70 per unit, still 7 times what Britain could afford for mass production. The gap between requirement and reality seemed insurmountable. Major Reginald Vernon Shepherd and draftsman Harold John Turpin began work at the Royal Small Arms Factory in December 1940. Their brief was simple: design a submachine gun that any factory could build using materials any nation could source at a price any treasury could afford. They had no time for elegance. German invasion barges were being assembled across the channel. Turpin handmade the first prototype at the Philco Radio Works in Paraval. He completed it on January 8, 1941, just 36 days after design work began. The name combined their initials, S for Shepherd, T for Turpin, and EN for England, though most assumed it meant Enfield. Colonel Shepherd later testified to the correct meaning, but the misconception persists. The weapon they created looked like plumbing. A steel tube with a wire stock, a horizontal magazine jutting from the left side, rough welds visible on every surface. Soldiers called it the plumber's nightmare, the stench gun, the Woolworth special. Every nickname dripped contempt for its appearance. That appearance was the point. Only the barrel and bolt required precision machining. The remaining 47 parts were stamped from sheet metal and steel tubing. A revolutionary cold hammer forging process developed by Walter Hackett of Ackles and Pollock produced one barrel every 10 seconds, eliminating year-long production delays that crippled conventional manufacturing. The entire weapon required 5 man-hours to assemble, compared to hundreds of hours for the Thompson. The Mk2 Sten cost approximately £2 at peak production, around $10 in American currency. For the price of 100,000 Thompson submachine guns, Britain could produce 2 million Sten. This was not a compromise, this was a strategic revolution. The German MP40, widely considered the finest submachine gun in Europe, cost approximately $24 per unit, more than twice the Sten. The Soviet PPSH-41 achieved similar mass production, but required more sophisticated manufacturing. The Sten alone could be built by anyone with basic metalwork equipment and a few precision components. Manufacturing dispersed across facilities the Luftwaffe would never think to bomb. Lines Brothers Limited, the Trey toy company famous for Meccano construction sets and Hornby model trains, became the sole producer of the Mark III variant. According to Royal Armouries records, they manufactured 876,886 weapons at their Matron factory before returning to toy after the war. When production ceased in autumn 1943, the toy company had become one of Britain's largest arms manufacturers. BSA produced over 400,000. The Singer sewing machine plant in Scotland handled Mark I production. According to contemporary accounts, subcontractors operated from stables, lofts, and even hen houses. Any facility with basic metalwork capability could contribute components. The Sten fired 9x19mm parabellum ammunition at 365 meters per second. Effective range was 60 to 100 meters. Magazine capacity was 32 rounds, though soldiers loaded only 28 to 30 to reduce spring strain and prevent jams. The weapon weighed just under 3 kilograms, empty, light enough to carry all day, concealable under a raincoat or behind a false wall. One specification mattered more than any other for resistance operations. Sten magazines were interchangeable with captured German MP40 magazines. This was deliberate. Resistance fighters could use enemy ammunition, captured from ambushed patrols or stolen from supply depots. Every German bullet could become a British weapon. The Special Operations Executive required something more specialized. The MKQ-S, where S officially meant special purpose, featured a ported barrel and a suppressor, containing multiple baffles. It reduced muzzle velocity to subsonic 305 meters per second. At 50 feet, the bolt action was louder than the shot itself. No visible muzzle flash, perfect for assassination. The suppressor lasted only one magazine of full automatic fire. Agents trained for single shots or short bursts only. Production of suppressed variants reached tens of thousands, though exact figures remain difficult to verify from primary sources. German special operations commanders reportedly studied and admired the Stein's design. Its combination of minimal raw materials and adequate battlefield performance represented exactly the kind of engineering efficiency that desperate wartime production demanded. When the enemy's commandos reverse engineer your weapon for their own use, the design philosophy is vindicated. Now, before we see how these weapons performed across occupied Europe, if you are finding this useful, consider subscribing. It takes a moment, costs nothing, and helps the channel cover more British innovations the world has forgotten. Back to the resistance. SOE delivered tens of thousands of Stens to French resistance networks through carpetbagger and other supply operations. The scale defies imagination. Operation Cadillac on July 14, 1944, Bastille Day, used over 300 aircraft to drop 3,791 containers, supplying the Maquis. The timing was deliberate. France's National Day of Liberation became the day when liberation finally seemed possible. Each container held weapons, ammunition, explosives, and instructions. By morning, resistance fighters who had been waiting for months finally had the firepower to paralyze German communications before the Allied breakout from Normandy. General Eisenhower estimated the French resistance equaled 10 friendly divisions by D-Day. That estimate translated to roughly 150,000 effective fighters, with British-supplied Stens forming a significant portion of their armament. Much of that combat power arrived in parachute containers stamped with British ordnance markings. Each weapon represented perhaps 15 minutes of factory time and a few pounds of British treasury expenditure. The return on investment was extraordinary. Poland received approximately 11,000 M2 Stens through airdrops, supplemented by over 2,000 weapons manufactured in 23 underground workshops. The Army of Criolla, the Home Army, developed their own variant called the Bliskavicker, meaning lightning. It combined Steen internals with an MP40-style folding stock. According to resistance accounts, they test-fired these weapons in locations where ambient noise would mask the gunfire. During the Warsaw Uprising, British aircraft dropped additional Stens in 186 sorties, though only a portion reached the insurgents. Danish resistance groups received thousands of airdropped Stens and manufactured hundreds more in workshops. The BOPA sabotage organization produced approximately 200 weapons in various locations, lending credibility to the claim that ordinary workshops could manufacture these guns. Norwegian resistance built several hundred Stens in basement workshops and secret rooms across Oslo. The highest-ranking Nazi official killed during World War II died partly because of Sten unreliability. On May 27, 1942, Czech agents Josef Gabčík and Jan Kubis ambushed SS Oberanführer Reinhard Heydrich in Prague. Heydrich was the protector of Bohemia and Moravia, architect of the final solution, one of the most powerful and feared men in the Nazi hierarchy. Gabčík stepped in front of Heydrich's open-topped Mercedes, raised his Sten Mark II and pulled the trigger. The gun jammed and failed to fire. This is documented historical fact confirmed by the weapon recovered at the scene, an extensive post-war investigation. Instead of ordering his driver to accelerate, Heydrich made a fatal error. He stood up to draw his Luger pistol. Jan Kubis threw a modified anti-tank grenade that struck the rear wheel, driving metal fragments and debris into Heydrich's torso. He died on June 4th. Medical analysis suggests multiple factors contributed to his death, including infection from material driven into the wound. The reprisals were catastrophic. Over 5,000 Czechs executed. The villages of Lidys and Lesy destroyed completely. 13,000 arrested. The abandoned Sten at the scene provided clear evidence of British organized assassination. This was exactly what German authorities dreaded about these weapons. Not the individual killing, but the proof of coordinated resistance supported by London. German occupation forces responded to armed resistance with extreme brutality, precisely because the weapons represented organized British support. The Naga-Nebel Decree of December 7, 1941, which Field Marshal Kittler later called the worst of all his illegal orders, targeted resistance supporters with secret arrest and disappearance. The decree specifically listed illegal possession of arms among offenses warranting deportation to Germany and execution. By April 1944, thousands had vanished into the night and fog of the Reich. The psychological impact extended beyond formal policy. German soldiers in occupied territories faced constant uncertainty. Every civilian was potentially suspect. Every package might contain weapons. Every barn might hide an arsenal. The Sten's industrial simplicity meant that even finding component parts, steel tubing, springs, firing pins, could indicate British support. The Sten's concealability magnified German anxieties. The weapon disassembled in seconds, hidden behind false walls, carried under civilian clothing. Any farmer might be armed, any shopkeeper, any priest. Wehrmacht forces became increasingly brutal in their responses, viewing entire populations with suspicion. Germany deployed 400,000 troops to Norway alone, outnumbering the country's 250,000 able-bodied men. While securing iron ore supply routes and guarding against Allied invasion were the primary reasons, armed resistance added to occupation costs. The weapon's reputation for unreliability was partially exaggerated, but grounded in real issues. The double-column single-feed magazine design required cartridges to merge at the feed lips. Rough handling deformed these lips from their precise 8-degree angle, causing jams. The open bolt design meant a cocked weapon dropped on its butt could fire unintentionally. 4 parachutists were wounded on November 16, 1942, from exactly this malfunction during a training jump. Early production quality varied dramatically. Weapons manufactured in late 1941 and early 1942 often used springs from bed manufacturers and bolts cast from soft bronze that wore too quickly. By contrast, weapons produced after mid-1942, once production lines had stabilized and quality control improved, performed reliably under combat conditions. Historian John Waller concluded that exaggerated reports about unreliability usually related to quality of manufacturer. Weapons from late 1942 onward were highly effective. Members of Britain's auxiliary units reportedly rated them more reliable than the Thompson. Soldiers learned the weapon's quirks. Load 28 rounds instead of 32. Never grip the magazine while firing. Test fire before combat. The plumber's nightmare served effectively until 1953. Germany's ultimate acknowledgement of British engineering came in 1944, when they began copying the Sten directly. The Garrett-Potsdam project produced thousands of copies manufactured by Mauser.
The MP-3008 was designed to require just 1 man-hour of production time, with production continuing until the war ended. The nation that built the MP-40, that prided itself on precision engineering and craftsmanship, resorted to copying British emergency manufacturing. The comparative specifications tell the story clearly. The MP-40 weighed 4 kilograms empty, a full kilogram heavier than the Sten, with similar rate of fire and identical magazine capacity. The Thompson M1A1 weighed 4.8 kilograms and cost between $45 and $70, depending on production year. The Soviet PPE-41 achieved a devastating 900 to 2200 rounds per minute from its 71-round drum magazine, but could not be manufactured in basement workshops by resistance fighters with limited tools. The Sten alone combined adequate performance with revolutionary accessibility. Any nation could build it, any workshop could repair it, any resistance fighter could maintain it. That accessibility mattered more than any specification. The Sten proved that crude engineering genius could defeat elegant craftsmanship when wielded by desperate ingenuity. Total production reached 4 to 4 million units, second only to the Soviet PPS-41, 6 million. It armed British commandos at DEP in August 1942, their first major test of the weapon under fire. It equipped paratroopers at Arnhem. It filled the hands of resistance fighters from the Pyrenees to the Polish forests, from the fjords of Norway to the streets of Copenhagen. Post-war service continued through Korea, Malaya, Suez, Cyprus, and Enya. American special forces employed suppressed versions in Vietnam for quiet operations. Israeli forces used Stens manufactured clandestinely in Tel Aviv and kibbutzim before 1948. The weapon appeared in conflicts across Africa, Asia, and the Middle East for decades after World War II ended. The Sterling submachine gun replaced
it in British service in 1953. Designed specifically to retain all the advantages and eliminate all the disadvantages of its predecessor, the Sterling addressed the magazine feed problems that plagued the Sten while maintaining the fundamental simplicity that made mass production possible. The lineage was clear. British engineers had learned from their wartime creation. German occupation authorities understood what the parachute drops represented. They could defeat armies, they could occupy nations, they could not defeat an idea backed by millions of cheap, ugly, effective weapons falling from the sky every night. Every village might contain a hidden arsenal, every civilian might be a trained fighter waiting for the signal. The mathematics were simple and devastating. Germany could not station enough troops to guard every railway junction, every power station, every bridge, every officer walking to his morning coffee. The Sten made resistance economically viable. For the cost of a single Tiger tank, Britain could arm thousands of resistance fighters. The Sten cost approximately £2. A German officer's life was worth less than a decent dinner, and every occupation soldier knew it. British engineering was not luck, it was innovation under pressure, producing weapons that worked when it mattered most. That is the story every abandoned Sten tells, rusting in museums from London to Warsaw, testament to what desperation and genius can achieve when conventional options fail.